Okay, have a look at part B. Which is more likely? A 1 or a 2 will show, or neither a 1 nor a 2 will show. Now, it didn't say it explicitly, but part B flows right on from part A, right? So the first part, the first half of part B, is this, right? Is this one here, okay? So the opposite, neither a 1 nor a 2, we have a word for this, it starts with a C, that relates it to this event. Does anyone remember? It's the complement, right? It's like the only way to not have a 1 or a 2 is these guys down here. Make sense? So, I'm going to say the probability rather of, I'm going to use the complement symbol, which is that big squiggly line over the top. Neither a 1 nor a 2, okay? That's going to be, and I'm going to write it because I've said this is a complement. The probability of a complement is 1 take away whatever the original probability was. So this is 1 take away that. So that gives you your answer. Which is more likely?
The first one.
Yeah, the first one. Not a huge amount, but enough. Okay. So therefore, it's more likely to have a 1 or a 2 than to not. As you've seen before, just like in calculus, Mathman, application questions, always look back, don't just do your calculations, see if you've answered the question. So that's not too hard. Part C, can you tell me what to do now? I held your hand through A and B. Where's part C? And this actually is going to refer to what Jan was pointing out before. You might like to get another colour in your hand. What would you like me to do?
Circle the ones that, so down the row of 4.
Yep.
Yeah,
This guy should be
Down the column of 4.
Okay, good. So I'm gonna start circling down this column here, right? But I stop here because what's the word that tells me to stop? Very good, only. So exactly one. So I stop there, right? So I can't do this one. This one's out. Okay. I can keep going though. Those have got a single 4. That's another word you could see, right? And then I also have to have these guys. Okay, does that make sense? So read carefully. A single word changes it, right? I've excluded the double, which means how many have I circled all up?
10.
It looks like 10, right? So the probability of a single 4 is 10 on 36, which is 5 on 18. Happy days? Okay, last one. The question says the sum of the numbers showing on the dice, the sum, is less than 5. Sum is less than 5. Okay? So what's the smallest sum I could have? The smallest sum has to be 2, right? Because, I mean, 1 has to be 1, the other one has to be 1. And then the biggest my sum can be is 4. Because, again, read carefully, it says less than 5, not inclusive. So I'm looking for all the ones where the sum is 2, or 3, or 4. So again, be systematic about it. One of the nice things about laying this out in a grid is if you find a pattern, it will mean something geometric on here. So here's a sum of 2. Where are the ones with a sum of 3? Yeah, I'm going to start to form like a triangle here, yeah? And then where are the ones with a sum of 4? Just keep going, yeah? Do you see why colours are useful? Just handy. Help you not misread your own diagram. Okay. So I've got them all. I have circled all the ones. Yeah.
You can't use the color images.
The colours are for you. The colours are for you.
But then
so you can read this thing.
They need to. You need to show the working.
If you've done this, right, and this comes up on the scan, this is not gonna, like, obviously not all of the colors are gonna come through. But like, even if you took a photo of this and made it in grayscale, I can see all of the things I need to see how this question was answered, or rather how each of these questions were answered. Okay, so this totally gets a pass. Again, remember the colors are primarily for you, because this gets really busy really fast. How many do I have? 6 out of 36. Okay. Lovely. Now, I'm just going to add one more thing because it's the perfect time to say it. When you've got a diagram like this, one of the handy things about like listing all the probabilities or having a dot diagram that exhaustively tells you the sample space is that were I to ask questions that included a condition, so this is conditional probability, right? Conditional probability is a bit confusing, but these kinds of things make mincemeat of conditional probability. I could change one of these questions. I could say, for instance, if I know that one of the dice shows a 1. I okay, I can re-ask any of these questions. Okay, I can re-ask any of them. So actually, I could re-ask all of them. If I know that there's a 1, how does that change the sample space?
It will reduce it by to 1.
So you've got this diagram now, right? You've got it. It's beautiful. Okay. If I know there's a 1, there's only 11 possible events out of my 36 that exist anymore, right? All of these guys, they're all gone. They can't possibly be happening because I just told you, I know there has to be a 1 in there somewhere, and all those ones I just rubbed off, there are no 1s. So they're no longer part of the sample space. So now all these are going to be out of not 36, but 11, okay? And then as you can see, well, because I got rid of so many, each of the numbers is going to be smaller, okay? So if the first 2 questions are trivial because they involve 1s, okay? But if I had to answer this, part C, what's the probability of getting a single 4 if I know there's a 1? 2 out of my 11, right? You see how I answer the question in the same way, the same principles, but I use the diagram to help me know what's going on. What about this last one? 1, 2, 3, 4, 5 out of 11, okay? So you can see conditional probability, it changes the sample space, and you use your diagram to help you work out what the new one is, okay? Any questions on that?
If we know that one dice is definitely 1, then how come it's not just like 1 row? How come it's the 2?
Yeah, that's a great question, okay? Why do I get both of these branches? Now, I don't have it written there, so maybe it's a bit tricky. The wording will generally be something like, if I know that one of the dice has a 1. Now, that doesn't tell you which of the dice it is, right? And in fact, when I roll it, I don't even know which one is which, unless like there's a color or something like that. Now, if that is the case, right? For example, say I have a red die and a blue die, okay? And then I say to you something like, I know that the red die has a 1, okay? That does change the sample space again, right? If I know the red die has a 1, then I have to get rid of even more, right? I have to get rid of these guys. Does that make sense?